Hi guys, welcome back. I hope you had a wonderful long weekend. Today's lesson is going to include 3 big new ideas. It's conceptual, so make sure that you watch the other video first in order to really get an understanding as to what this is about. And then the little video that's after this will kind of help solidify and give you some visuals to understand this. So we're learning about standard deviation and normal distribution today. We're also going to learn about margin of error and what these all have to do. And the basic idea is standard deviation is how spread apart data is. So what that means is if you found out the GPA of every junior at SLJ and you averaged it and you found that the mean was an 82, and then you said, oh, well, the standard deviation is a 10, right? So that means that if you go 10 points above and 10 points below, a chunk of students are going to fall in that. And then if you go 10 more above that and 10 more below that, almost all the students are going to fall within that. So if the average was 82 and you go 10 below and 10 above, that's 72 to 92. So that means that most students are between a 72 and 92. And then if you go 10 more between a 62 and 102, or 100 because that's the highest you can get, that means that almost everybody is in that range. And that makes sense. So that's what standard deviation is, okay? A low standard deviation means that most of the numbers are close to the average, and a high standard deviation means that there's a lot of spread, so the numbers are very spread out and far away from the average. This is the formula here for standard deviation. However, you don't need to learn that. It's complicated, it's got a lot of stuff going on, and I'm going to show you that in the calculator, all you need to do is from last week's where you learned to use the calculator, this is the symbol that means standard deviation. So that's it. We're going to be using the calculator for everything. Okay. Normal distribution. So make sure you're pausing and taking really, really good notes on everything. Those notes are one of your grades. And since there's only one lesson this week, it's a double credit lesson. Okay. Normal distribution. So normal distribution, undo. Okay. Is where you have the average right here. Okay, so this is the average. And those are both symbols that mean average. So this is the average right here. And we're saying that half of the data is above. Okay, so that's everything over here. And then half of the data is below. So that's what normal distribution means. And it means that a lot of it is within one standard deviation, and then a little bit outside of that, and then a really teeny bit is far away. So it's saying you don't have a lot that would be on one side. Income is not normally distributed because income, a lot of people are in the lower end and only a very few people are in the high end. Okay, so that would be a non-normal distribution. So, normal distribution is a symmetric distribution where most of the observations cluster around the central peak and the probabilities for values further away from the mean taper off equally in both directions. Notice how low the percentages are, okay? Now, if I add up all the percentages on one side of the average, guess what they're going to add up to? Did you guess 50%? You were right. Add those numbers up. 34, 13.5, 2.35, and 0.15. That's 50% of the data. Other side, the other 50%. Couple things to note. Notice how absolutely small it is when you're getting out here. So it's saying that less than 1%, almost nobody, is going to be that far away from the average when it's normally distributed. Okay. Here are 2 examples. So let's say that we're looking at a group of high school friends and a group at a family reunion. In the high school age friends, the mean age is 16 and a half years old, and the standard deviation is 1 year. In the family reunion, the mean is 32 years old, but the standard deviation is 19 years. So let's see what this actually means. So we always put the mean here in the middle. So I'm going to put the 16, I'm so sorry about this, the 16.5 in the middle. And since it's one standard deviation, this is plus 1 standard deviation, this is plus 2 standard deviations, and this is plus 3 standard deviations. So it's 1 year, so that means that this would be 17.5 years old, 18.5 years old, and this one would be 19.5 years old. Then going down, we're subtracting 1 year. So this is 15.5 years old, 14.5, and 13.5. If we go back to the last slide, remember we saw that these percentages, right? We had 34% within here, okay? 13.5% there, and then only 2.35% getting out here. So looking over here, that means that 34 and 34, that's 68% of the people are between 15 and a half and 17 and a half years old. That makes sense for a group of high school students. It also tells us that 95% of the people are between 14 and a half and 18 and a half years old. So there may be somebody, one person or something that's a little bit below that, but almost nobody is going to be outside of that. Now let's take a look at what it means. So this is a low standard deviation because it's only 1 year. Here we have a high standard deviation. So our average was 32. We add 19, so 32 plus 19 is 51. We add 19 again, another standard deviation, that's 70. And we add 19 one more time, and that's 89. Then we're going to subtract the standard deviation. So 32 minus 19 is 13 years old. And minus 19 again is negative 6. And minus 19 again is negative 25. Do any of these ages matter? No, because nobody can be negative 6 years old. So again, we know there's going to be almost nobody out in that range. So this tells us that the majority, that 68% of the people are between 13 and 51, and 95%, so almost everybody, is between 0, because you can't be negative, and 70 years old. So this is a high standard deviation. High standard deviation because everyone's age is very spread out, and a low standard deviation because everyone's age is close in age. So take a minute to write down some notes for yourself to understand what standard deviation tells you and what a low versus a high standard deviation is. Make sure that you also wrote down this table, so if you need to pause it, okay, to get this really important normal distribution with these percentages on it. Okay. Here's the empirical rule, and this is a really important rule that you're going to hear about a lot if you do use statistics or probability in college and in life. So this is what we just talked about. 68% fall within one standard deviation of the mean. So we can see that right here. 68% are either one above or one below, anywhere in that range of the mean. So in the last case, that meant that between 15 and a half and 17 and a half, 68% of the students fell in that range. Okay, 95% fall within two standard deviations, and that's the important one. That's the one that's really going to be important. So notice it's written the mean plus or minus, so 2 above or 2 below, 2, and that's the symbol for standard deviation. And then 99.7% fall within 3 standard deviations of the mean. So that means that almost 100%, right? Like almost every single person. There might be one small data point that's outside, but almost everything is within that. Now this is really important, so make sure you take all of this down in your notes because this all is really important. The empirical rule tells us that when data is distributed normally, if a piece of data is within 2 standard deviations, it is to be expected. So that means that it's normal, it's to be expected, we can't get upset about it. But if a piece of data is outside of 2 standard deviations, it is very rare and unusual, and therefore you need to investigate why that happened. Everything on this page is super important, write it down. Okay, now we're going to learn how to use the calculator to actually do problems with this. What does it actually look like? So let's read the problem. The amount of time a certain brand of light bulb lasts is normally distributed with a mean of 1,100 hours, so that means that that's on average how long it would last before it burns out, and a standard deviation of 20 hours. Using the empirical rule, so that's what we just learned, what percentage of light bulbs last between 1,060 hours and 1,140 hours? So what we're going to do is put the mean right here in the middle, right? 1 standard deviation above would be 20 more than that. 2 standard deviations above would be 20 more than that. And 3 standard deviations above would be 20 more than that. A standard deviation below would be 20 less. 1080, 1060, and 1040. So it asks us what percentage are between 1060 and 1140. So here's 1060 to 1140. That is 2 above, because this is 1 above, and this is 2 below. So if you remember from the last thing, we learned that 2 above and 2 below is 95%. So that would be 95%. Now I'm going to teach you how you can use the calculator to do this as well. So You just need to enter the numbers from, first, calculator steps. Write down these steps. They're super, super, super important. First, you have to identify the mean and the standard deviation. Then in your calculator, you're going to push, and I'm going to show you how you can use Delta Math Calculator as well. It does the same thing as the TI-84. Second, VARS. VARS is right near the clear button, and that means distribution. So that's what we're learning about, is distribution of data. Then you're going to choose normal CDF, okay? Little note, you would never use normal PDF. We're only using normal CDF in almost everything you would ever need. Now, you just need to enter the numbers from the problem in the calculator in order. So this is the rule. The rule goes the lower boundary first. So what was the lower number? 1060 was the lower number, so that's my lower number. Upper boundary second, that was 1140. Then the mean, which is 1100, and then the standard deviation, which is 20, and you hit enter, and your calculator will give you the percentage. So write down these steps because you're going to be using this a lot. I'm going to show you in the calculator how to do this. Delta Math. Sorry. Delta Math. Okay, there we go. Okay. So let's say. So on the top, you're going to choose the calculator and you're going to choose statistics calculator. Okay, we don't need to enter any data right now because we don't have it. We're just doing distribution. So that was like the second VARS. We're going to choose, like I said, we're always using, remember, normal CDF. Okay, so we choose normal CDF. The lower bound you would put in was 1060, 1140, 1060, 1140, I believe it was 1120. Oops. 1120. And you hit calculate, and there you go, 95%. Okay, and you have to turn the decimal into a percent by moving the decimal place 2 spaces over. Okay, now we're going to just practice this. So, Serenity commutes to work. The amount of time it takes her to arrive is normally distributed with a mean of 28 minutes and a standard deviation of 3.5 minutes. We're going to use the empirical rule. So we want to say, is it within 1 standard deviation, within 2, or within 3? So the mean is 28, and I'm going to do it the long way first. 28 plus 3.5 is 31.5. And I can see that's my number here, so I don't have to keep going. And then I go 28 minus 3.5 is 24.5. And that's my lower number. Okay, so that's what I'm finding. It's within 1 standard deviation, and we learned from the empirical rule that 1 standard deviation, keeps popping up, is 68%. Okay, 68% right there. So that's going to be 68%. That's your answer. If you want to use the calculator, you would just enter the lower, this number, the upper, the mean, and the standard deviation, and hit enter, and it's going to give you that, and then just round it to a whole number. Okay, let's keep going. IQ scores are normally distributed with a mean of 100, standard deviation of 15. Using the empirical rule, determine the interval that would represent the middle 99.7%. So I go back over here, and why does it keep doing this? 99.7, I see, is 3 above and below, so that's what I have to do. I have to go 3 above and below. Here it keeps going to the top, the other one it keeps going to the bottom. It doesn't like me. So I have to go 3 above and 3 below. So I start at 100, and I'm going to add 3 standard deviations, and I'm going to subtract 3 standard deviations. Since the standard deviation is 15, right, it's like 15, 15, and 15, or we can say 45, because it's 3 times 15. And 100 plus 45 is 145, and 100 minus 45 is 55. So you can either write it in a sentence, the interval is between 55 and 145, or we can use interval notation, so we do parenthesis 55, comma, 145. That means everything between 55 to 145. Okay. In an all-boys school, the height of the students' student body are normally distributed with a mean of 71 inches. And this is so important. If it doesn't say normally distributed, we can't use the empirical rule. And a standard deviation of 3 inches. Out of the 696 boys who go to that school, how many would be expected? So notice it's not a percentage now. We actually want to find out how many people would be expected to be shorter than 74 inches tall. So we're going to learn how we use the same calculator trick, okay? But we're going to not have both numbers. I'm so sorry. Okay, there we go. So we always do the lower first, upper, mean, and standard deviation. So our lower, it says they have to be shorter than 74. So could they be 73, 72? They could be anything less than 74. So what we're going to write in is the smallest number, meaning you put negative and then you just put a bunch of nines. We always use 6 as a standard, right? So this is the smaller number, okay? Then the upper is 74, because that's as high as we want to go. We don't want to go higher than that. The mean is 71, and the standard deviation is 3. If they had said above 74 inches, then the lower would have been 74, and the upper would have been positive 99999. You're just putting in a really big number. That's the whole idea. A really small number here and a really big number here. So if it's lower, really small, upper, really big. Okay. Enter that in your calculator, and you're going to get the answer, and then it says the nearest whole number, so you round it to a whole number. So we're going to put in negative 74. I don't remember the average. It was 71 and 3. And we hit calculate, and we turn that into percent, so you move the decimal twice, 84. And so our answer would be 84%. Oh no, it would be 84%. We have another step though. It didn't ask for the percent, it said how many students. So I have to find 84% of the 696 boys in the school. So I do 0.84 times 696. 0.84 times 696, and you get 585 students. So that's how many out of the 696 would it be shorter than 74 inches tall. Okay, a couple more, and then that's it. When Harper commutes to work, the amount of time it takes for her to arrive is normally distributed with a mean of 30 minutes, standard deviation of 3. What percentage will be between these two numbers? So again, we're just going to use the calculator. Lower is 25, upper 37, mean 30, and standard deviation 3, and then hit enter and round it to the nearest tenth when you convert it to a percent. So 25, 37, 30, and 3. 25, 37, I already forgot, 30, 30, and 3. Okay, so I convert that to a percent, 94.2%. What do they want me to round to? So this would be 94.2%. Okay. Last one of this before we move on to the last topic. On a test that has a normal distribution, a score of 33 falls 2 standard deviations below the mean. So picture this, right? Here's the mean. 2 below, okay, is 33. A score of 63 falls 1 above. So 63 would be right here. Well, I have to find out what the mean is. Well, if I think about it, you kind of just have to use some problem-solving skills. How many standard deviations are between 33 and 63? Well, there's 3 equal spaces, right? 3 equal standard deviations. So from 33 to 63, we subtract those, is a 30 gap, which means that each one has to be 10, because 30 divided by 3. So I just now can find the mean. 33, this one would be 43, and this would be 53. And so the mean is 53. Okay, the last thing we're going to learn about is margin of error. So margin of error is actually when you do an actual survey or an actual experiment, it's the measurement of how accurate your actual survey is as a sample statistic relative to the entire population. So it's how accurate is this going to give, how specific and accurate is this going to be when I look at the entire population? For example, if you only survey 4 people out of all of SLJ, it would not give you a good sense of what most people would say. Therefore, there would be a lot of error in the survey. The margin of error would be really high because it wouldn't be able to really tell you what most people think. But if you at SLJ surveyed like 300 people or 350 people, it would give you a really good idea of what people would say. So let's look at an example. A Gallup poll is conducted at SLJ to determine how many people believe in the afterlife. Remember to pause this and take notes on things that are important. They find that 62% said they believe in the afterlife. The poll reported a margin of error of 3%. So this was their finding. 62% of the people they surveyed said they believe in an afterlife with a margin of error of 3%. So what does that tell us about the entire population's belief in the afterlife? Well, we can infer, and infer means that you can believe that information based on the data, that we're confident that the true percent of people who believe in the afterlife lies within 3% of 62%. So that means that we can, with confidence, we can say that in the entire population, it could possibly be as low as 59% or as high as 65%. So with confidence, we can say that the entire population that believes in the afterlife will fall somewhere between 59 to 65%. Well, that's pretty good, right? It's a small margin of error because that's a small change, 59 to 65%. That gives me an idea about how many people believe in it. But let's see what happens. Oh, wait, no. Okay. Oh, my God. This is driving me nuts. The 95% confidence interval. This is really important. This is a formula you do need, so write the formula down. This is how we calculate margin of error. Everything else you can do in the calculator, not this. Margin of error, the formula is 2 times the square root of the probability of what's going to happen as a decimal times the probability of what's not going to happen, which is 1 minus p, divided by n, which is the size of the population. So let's do it one together. If the Gallup poll that found that 62% of people believe in an afterlife had only surveyed 4 people, how much margin of error would we have had? Well, the p would be 0.62 because that's the probability that someone believes in the afterlife. This would be 1 minus 0.62, okay? And the n is 4. So the formula we write out is 2 radical 0.62 times 1 minus 0.62 over 4. Now, you're going to use your calculator, but the only thing you want to do first is simplify this part. So you do 0.62 times parenthesis 1 minus 0.62, and you get 2 radical 0.2356 over 4. Now you can type this straight in your calculator. 2 square root 0.2356 divided by 4, enter. And you get 0.48538. Convert that to a percent, and it approximately is 49%. So the true percentage is between, so remember it was 62% is the mean, plus 49% margin of error, and 62% minus 49%. So that's 13% to 62 plus 49 is 111. Well, you can't have more than 100%. So because 100% means it's definitely going to happen. So this tells us that if we had only surveyed 4 people out of the whole school, we can assume in the entire school that somewhere between 13% to 100% believe in the afterlife. Does this tell you much about the people at SLJ? No, it doesn't, because that range is way too big. So our margin of error was really high, meaning that it's not very good data. Now let's see what happens. Come on, please just work. There we go. Okay, if we had surveyed 390 people, so same exact formula, 2 radical 0.62 times 1 minus 0.62, but now we're over 390. So again, we simplify the top part first, 0.2356 over 390, and then we just type it straight in our calculator, and when we do that, we get 0.04915, convert that, and it's approximately 5%. That tells us that 62 plus 5% and 62 minus 5% is going to be between 57% to 67%. That means that if we actually surveyed 390 people out of the whole school, we would know that the whole school would fall somewhere in this range. That if we actually surveyed every single person, the answer, the percentage of people that believe in an afterlife would fall somewhere within that. That's what a confidence interval is. It's saying, with confidence, what can you say the entire population would believe? Okay, last one, and then that's it. And then you can actually practice, and that's all you have to do this week. I know this was a very long video. Thank you for staying with me. It's like a real lesson in class. A May 2000 Gallup poll found that 38% of random sample of 1,012 adults said they believe in ghosts. Okay, so what percentage of the entire population say that they believe in ghosts? Well, we need to find the probability that someone surveyed believes in ghosts. That's 0.38. Okay, and then this is 1 minus 0.38. And the sample size is all the people that were surveyed. So it's the sample, the number of people surveyed. So if we want to say that we're 95% confident, okay, about how the real population would respond, we need to include the margin of error. So it wouldn't be exactly 38%, it would be somewhere in a range around that. So let's calculate it. We also want to find out, is 45% a reasonable value for the actual value of the percent of the population that believe in ghosts? Well, if it falls within the range, the 95% confidence interval, then yes, it's a reasonable value. And if it's outside of it, then no, it's not reasonable. Okay, so we do margin of error equals 2 radical 0.38 times 1 minus 0.38 over 1,012. And again, we just do 0.38 parenthesis 1 minus 0.38, and we get 0.2356 over 1,012, and we type the entire thing in. 2 radical 0.2356 divided by 1,012, enter, and we get 0.0305, which is approximately 3%. Okay, so we have to go 3% above and 3% below. So 38 was the average, okay? So 38% plus 3% and 38% minus 3%. So with 95% confidence, I can say that when I did minus, I got 35%. When I did plus, I got 41%. So between 35% to 41% of the population would say that they believe in ghosts. Is this within that range? No. So this is not reasonable. Okay. And that's everything you're going to be practicing. I know that was a lot of information. I hope you took really great notes. You get a grade for your notes and a separate grade for the Delta Math. Make sure you show work. Have fun. I will see you next week. This is all you have to do for the entire week.